Hello guys, welcome back to the YT University, and in this video I'm gonna teach you how we can plot vector arrows using Python. Alright, so here is the code. This code will ask you to install Python and install some library. So if you have not done that, please do so. You have to install the math library, the NumPy library, and the matplotlib and pyplot library. Alright, so um, there are documentation on this process which you can find in this one, um, matplotlib.pyplot.ro, on how you can make your own vector arrow. So there's another process which is Quiver, but the problem with that process is I cannot modify the length of the vector in the way that I want. So I just wanna make use of a certain Cartesian coordinate plane that I can manipulate, okay, which I can input some points and draw some arrows which will correspond to my vector arrows, which I can manipulate and I can animate later on. So that will be the target of this project. Okay, so let's go ahead and go back to the code. So here, as you can see, you have to import math, you have to import numpy, so and then as np. So what it does is it tries to abbreviate numpy, because mentioning numpy or typing numpy is a little tedious, and abbreviating it is much better. So whenever you type np or say np or invoke np in this process, you are making use of the numpy library. So same is true with matplotlib.pyplot. We just abbreviate it to plt. So whenever we write plt, that means we are making use of the matplotlib and pyplot library and all of its functions. Okay, so in this part, we're going to define the minimum and maximum values or of the coordinate. Okay, so I have here some, I think I can split some screen. Well, split screen. Okay, and here we go. This is what I'm doing earlier. So this is the maximum value that it can be plotted for the x and y, and then I need some grid later on. Alright, so this code does that. Okay, it defines the boundary or the size of your Cartesian coordinate plane, and then the figure size is 10 by 10. So this might 10 inches by 10 inches, so that's, or 10 cm by 10 cm, I'm not sure, but basically this will be the size of the window, and then the color, so it will look like white. So this FFF thing is a code that tells or pertains about the color, and then AX dot set. Okay, the limit, X limit, is equivalent to x min minus 1, and then x max plus 1. So, and then aspect, yeah, equal. So it's basically a specification of how your Cartesian coordinate looks like. Okay, and then we go back here. So we're going to add the grid. Okay, so you can change the color of the grid. Okay, but we want to make sure that it's not as bright as other colors, so that we can still see our arrows. Alright, so here is my addition to this program. Okay, so I think I can close that. So plot.arrow, which is mentioned here, matplotlib.pyplot.arrow, you just have to copy this. Okay, there's no other trick behind this. Copy it. Okay, and then paste it here, and then plot.arrow, and then this one is the starting point for the x-axis, this is the starting point for the y-axis, this is the ending point for the change in x, this is the change in x, and then this is the change in y. This is for your vector 1. Okay, so plot dot plt dot arrow will graph an upward arrow whose origin is at 0 and 0, and whose head is at 0 and 1. Okay, so the color will be black. So I just found out that FC here is for the color and EC is for the layout color. And here is how you can change the size of your arrow. So head width, head length, and width of the entire arrow. Okay, so for the next vector, this is a vector pointing alongside the x-axis, and it's gonna be red. Okay, so the next line of code is we want to show that show everything. Okay, so we save that and we try to run it. Okay, I think I want to go here and okay, um, click this one. So if you have set up the Python correctly with the Visual Studio Code, there we go, it will work properly by just clicking this one. So if you were not able to set up Python environment, okay, the Python interpreter path whatsoever is that, I think it's not gonna work as easy as that. Okay, even if you have the right code, just like this entire code. So you should be able to set up the Python environment in your PC to make use of this. Okay, so it's not a part of our video. So there are tutorials on how you can do that. But nonetheless, our program here is successful. So there's a vector here whose origin is at 0 and 0, and the arrowhead is at 0 and 1, and this one. Now, um, the thing is, I want an animation because these vectors are interacting. Where would the resultant force be? So that's gonna be done by vector addition, and um, thank goodness we can import the math here, so we can do the Pythagorean theorem inside, and we want to see the endpoints, and we can plot that here, somewhere here, and I can animate. I think I can animate how it moves little by little, and that's what I want. Okay, so I think we can scale it up to zoom it in or zoom it out. So there's a lot of things that you can still do with this simple program that I will share in GitHub. Okay, credits to the original writer of the earlier part of the code. It so happened that I forgot where what tab. Okay, so yeah, but I'm going to place it in my GitHub, and I'm gonna put the links in the description box below where you can get this code. Alright, so guys, um, well, you can make use of this like in the forces that are interacting, using electromagnetic waves, electricity. There's a lot. Okay, it's up to you. Okay, so it's for future development, future use. Okay, so thank you for visiting and dropping by here in the YT University. Okay, thank you for all of your support. Thank you for subscribing, and thank you for clicking the notification bell. And see you next time here in the YT University.